Hi everyone. It became clear to me that there's a few people who are still very much struggling with algebra, so I thought I'd do a quick video on algebra because why not? Let me see if I can make this work. So it turns out you didn't use trig in everyday life like your maths teacher promised for the last 10 years. I get it. I was so happy when I left school because I was never going to do mathematics again. It's been about 20 years, a PhD and a change of century, and here we are. So anybody can do maths. We just need to frame it in a way that makes sense for you. Um, so introducing algebra, your new best friend, it's like any other human language. Stop thinking about it as some esoteric weird thing. It's just a language. Some human languages are quite simple. Algebra is one of them. Some are much more complex, like English. So if you've learnt to speak English, then you can manage algebra. You need a vocabulary and practice, but you can do it. Mostly the most important thing you need to know is that you don't need to know everything. You just need what you need right now. So let's start with a few basics. Adding and subtracting. So in algebra, letters are just unknown quantities. We can use them to step in or fill in for real numbers, but they still work the same. So if x is 10 and y is 2, then x plus y is the same as 10 plus 2, and that's 12. And x minus y would be 10 minus 2, and that's equal to 8. Not so bad so far. Multiplying and dividing works the same, but sometimes we just drop the star or the x for dividing. We just say 2x is 2 times x, okay? So 2x is 2 times 10, which is 20. 2y is 2 times 2, which is 4. xy is the same as x times y, which is 10 times 2, which is 20. Dividing, x divided by y is 10 divided by 2, which is 5. And x divided by 3 is about 3.333, or 3 1/3. Okay, so far so good. Exponentiation, okay, just think of that as to the power of. It's sometimes shorthanded with a caret. I use that particularly when I'm trying to type something out quickly, but usually we'd use a superscript like this. So x to the 2 is x squared, and that's the same thing as 10 times 10 in this case. That's 100. X to the 3 is x cubed, so 10 times 10 times 10, it's 1,000. And x to the 4, we sometimes refer to that as a quartic, not very often. And here you can see I've done a typo there. It should be 10 times 10 times 10, so 4 tens, 10,000. You get the idea there. Exponentiation also applies to fractions too, so you can get those exponential terms in fractional terms. So x to the half is the same thing as the square root of x, which you've probably heard of. X to the third is the cubic root of x. Other fractional powers don't really have special names, but they all work the same. You punch them into the calculator the same way. Now, so far we've only looked at things happening on one side of the equal sign, but we can push quantities back and forth across both sides to meet our requirements. Quite often you'll have an equation and it won't be quite what you need it to be, so you can manipulate it. The golden rule is whatever you do to one side, you do to the other. And what really confuses people when they haven't been looking at algebra in a while is when we fail to mention this thing. We just assume that you know that obviously we divided both sides by x or whatever it was. So let's put this all together for finance. We'll just take a look at the compound interest formula or the future value formula. So it's the future value is equal to the present value times 1 plus r to the n. Now, if you're not sure about something called the order of operations, check out that video, which is also located in the flashcards thread or on this YouTube account, depending on how you ended up here. Okay, that will explain what order we punch things into the calculator. So if we want to find the present value from the future value formula, we can take a little bit of algebra to do it. So we want the present value on its own, okay? We want to get rid of this term here, this 1 plus r to the n. So we can divide both sides by 1 plus r to the n here. But you can see here on this side, if we've got 1 plus r to the n on 1 plus r to the n, we're dividing a number by itself, and that's just equal to 1. If you multiply any number by 1, the present value times 1 is just the present value. So we can drop this term now. That was the whole point of dividing this half by 1 plus r to the n. Now if we turn that around a bit, because usually we like our landing pad to be on the left-hand side, that means that the present value is equal to the future value on 1 plus r to the n. So we got there. We worked it out. Let's do some tricks with exponents now. So again, those powers to the term of. So x to the power of 1 is just equal to x. Okay, if you raise something to the power, it's just x. Another trick, piece of trivia that you need, is that x to the 0 is just equal to 1. Okay, and that's just maths trivia. We don't need to worry about proving that. Just have that one in your back pocket. Okay. Now, exponentiation terms can be a pain in the denominator. So here's another trick. 1 on x is the same to x to the minus 1. Okay, that's handy. If you have a term in the denominator at the bottom of the fraction, you can raise it to the negative of its exponent. In other words, our present value formula that we worked out was the future value of 1 plus r to the n. We can change that to be future value times 1 plus r to the minus n. That means all of that is underneath on the denominator. So either way is fine, just one can be more convenient sometimes. So that's another trick. What if we have the present value and the future value and we want to get that? Now I've done this one before, but let's go at it again, and this time we're going to take it real slow. So here we've got our original formula, and we divide both sides by the present value. So we've got the present value here and here. This part here is obviously going to be equal to 1, so we can drop that bit, and we're left with just this formula here. Now we need to get rid of this n bit, and that's the tricky bit. So what we're going to do is raise both sides to the power of 1 on n. Okay, so we've got here on this side n times 1 on n, which is really the same as n on n, which is equal to 1. So we can drop that bit, equal to 1. On this side we have the future value and present value to the power of 1 on n. Note where the brackets are. Okay, so that applies to all of it. So we've been left with this term here is equal to 1 plus r, but we just want r on its own. So if we take 1 from both sides, so 1 plus r minus 1 is just equal to r, and the future value on present value to 1 on n is just equal to that minus 1 here, and then we get r. Okay, and that's how we ended up with that. So thank you very much. Look out for further videos. We'll be going through these, and if you have any questions, let me know.